Welcome back everyone to Data Science for Everyone. Today we're going to be talking about JavaScript basics. Let's get started. So to introduce everything that we've been talking about, we're going to look at the basic ingredients of what make up a JavaScript program. Now you'll learn the fundamental units of JavaScript code, and we'll also talk about representing values and giving instructions to your computer. Now you'll also learn how to assign a name to a value so you can refer to it later on in your code. Now, specifically, JavaScript actually is going to categorize variables into different types, data types, okay? And this kind of information and value that anything can represent. Now, we'll focus on primitive data types and we'll represent individual values, such as a single number or maybe a piece of text. Now, you'll also practice working on different primitive data types in the JavaScript console and explore some of the operations that you can apply them to. So, first off, we can do expressions and statements. So we can do something like 1 plus 2, that gives us 3. We can do 5 plus 6, gives us 11. So you can use this as a basic mathematical operations, or you can use it as a calculator, right? Now the main expression in this statement, so for example, 5 plus 6, is known as a compound expression. Now it actually contains two smaller expressions, right? It contains 5 and it contains 6. Now these are examples of the simplest form of an expression in JavaScript. Now the literal, which is the direct representation of some sort of fixed value in code. Now these here, okay, are numeric or number literals, okay, because again, they are numbers. Now also we have an operator. An operator is this plus sign here. Okay, and that is a symbol used to combine or manipulate expressions. So we have other types of operators, right? We can do 5 plus minus 5 is going to give us 0, or 5 minus 4 gives us 1. We can do 1 divided by 2 to give us a half. We can do 5 multiplied by 8 to give us 40. Again, you can do 8 divided by 5. Okay, and again, you can do all of these. All right, and this is, but now, the next thing we need to talk about quickly is the order of operations, okay? So, order of operations, so 5 plus 10 divided by 10 minus 5. Okay, this gives us 1. So how and why is this happening? Okay, well, when you have multiple operators like this, JavaScript utilizes the standard mathematical PEMDAS. So we do parentheses, exponents, multiplication, division, addition, subtraction, or PEMDAS. And that's the rule, is to determine the order of calculations. So the division operator is in this expression takes the first place. So here, this would be 1, okay? And then we do addition. So we would do 1 plus 5 is 6, minus 5 then is 1. Okay, so now what happens though if we want to force addition and subtraction to happen first? Well, we can use the parentheses, right? So we do parentheses 5 plus 10, okay, divided by 10 minus 5, okay? And now this is going to give us 3. Again, the order of operations matters here. We'll go on and run that. So the next point that we have is floating point. Okay, now some people may also call this a double or just a decimal point or whatever, but again, you can do 2 divided by 4, again, is going to give us 0.5. Okay, so that's with the decimal. Now you could also do something like 2 divided by 3. Okay, and you can see here this floating point numbers do have a limit on their precision. Okay, it'll go off usually about 16 to 32 numbers, depending on how you want to set it up. Now you can also notice though that there may be some kind of weirdness happening here. Okay, so you could do something like 0.1 plus 0.2. All right, and then you notice this isn't quite right? There's this error here. Now this is some weird quirks of floating point math. where the answer doesn't quite get you what you expected, okay? So again, here we're getting a 0.3 with a ton of zeros and then a 4 at the end. Now, this is due to underlying mathematics of how computers represent numbers. And again, if you want more on this, you can Google floating point arithmetic or something to learn more about that. And again, it can always cause us some problems, but we'll teach you guys how to deal with that in the future. Now, the next thing is binding, okay, or bindings. Now, JavaScript can associate a name, okay, with a value, and this association is called binding. Now, it's a very powerful tool. One way of binding is a variable, okay, and another type of binding is a constant. So, what are variables? Okay, well, they're kind of a storage unit for things. Okay, you can use two keywords to declare variables in JavaScript. You can use var, okay, and we can use let. Now, a keyword is a built into JavaScript language, and it's reserved for that specific purpose. Now, originally, var was the only option that we had. But let was later added to fix some of the shortcomings of var. So today it is preferred keyword. Okay, so let here, let is our preferred keyword. Okay, for declaring variables, and that's what we're going to utilize throughout this course. So we can do let age equal here, and notice that this comes up as undefined. Okay, now we are currently declaring a variable here, and it doesn't have a value. Now, so the reason that this doesn't have a value, okay, is because we didn't put anything, we didn't assign anything to it, and that is also why it is coming up as undefined. Now, we can let that variable actually write something up. We can do something like age is equal to 45. Okay, and now notice it comes up as 45. Again, if we type up that age again, it comes up. Now we're using here the assignment operator. Okay, this is not the equal sign, this is the assignment operator. Now, again, notice we have the variable, we have the assignment operator, and we have what is being assigned to it. Now, using the assignment operator makes this a compound expression, okay? So the next thing that we can do though is we can actually go on and we can say something like let kids equal to 3. Okay, so we can basically create up a variable, okay, using let. We can also use the assignment operator to assign a value to this all in one line. Okay, and again, we can go through and say here, we can say kids. All right, and notice it does still store it. Now, another thing that we can do though, is we can do kids is equal to 2, and we can overwrite kids. So now kids is equal to 2. Now, this is great about variables that they can change their value. Again, they are variable in nature. Now, we can also declare constants in JavaScript using the const keyword, const here. And then, so for example, we can create up, let's just do pi. Okay. Now, again, let's not do pi. Let's actually just say, I don't know, code number here using camel case. Okay, code number is going to be 333. Okay, well, this creates up a new constant called code number, and it assigns the value 333. Now, what we can do with this though is now this constant is determined. You cannot change it. So if I do something like code number is equal to 23, notice I get an error here, okay? Don't freak out if you get errors, it's okay. Errors happen all the time. Okay, so I can open it and you can see here, uncaught type error, assignment to constant variable. And again, it tries to tell you where this was. Well, this is in the 12th line of our code here. Well, so if you get that, then you can actually just read it. Okay, you read, yes, uncaught type error, but then read what's after the colon here, assignment to constant variable. And again, it knows that you're making that problem. So we can do some other things with this, right? So let's go back to creating up a maybe let's do this. Let's create up a tax rate. So let's say const tax is equal to, let's say, 1.08. Okay, that's constant. Now let's have a let quantity is equal to, let's say, 20. And then let's also make up a variable for the a price. Price is equal to 2.4. Okay, well, now we can create up a new value here, right? We can say let total is equal to price times, price times quantity. I did it again. There it is, quantity. Okay, and again, let's say multiplied by the tax rate. Okay, so we are creating up a variable. We want these two variables here to be multiplied by the constant of the tax rate. And we should now be able to get a total, okay, of 51.84. In this case, it would have been dollars. So we're able to create up and determine our total price on something. Okay, that's great. So we utilized all of these variables and we're able to have all kinds of fun with it. Now, another thing though that I showed you the error previously. We can also do have another error here with constants. We can do const of let's say beta. Now notice here, if I try to create up a constant and it says missing initializer in const declaration, because it is a constant, you don't want an unnamed constant. Okay, it's impossible. So it will also give you up another error there. You always need to assign it to something. Okay, now again, you saw me putting this all uppercase, okay? You also saw me before utilizing lowercase. So let's talk about some naming conventions. So first off, you should give variables and constants descriptive names so that somebody else reading your code actually knows what it is. So it's clear that what a variable should be and what it contains, or what a constant contains and what it represents. So for example, if you're doing something with like speed in miles per hour, right? So you could do speed in miles per hour, but this is really long. So you could actually, I would say, edit this to do something like, let, for example, though, speed in mph. Okay, this at least tells people that what this is, and it's quite clean. Now, notice here, this is called camel case. Okay, you can create that up. Now, another way we do sometimes create up variables is let speed underscore in underscore mph, and this is called snake case. All right, now the next thing that we could also do is we could do something we could also do let speed, okay? We could do let speed. Now notice all of these, so this one here, this is speed, this is speed. Now we could also say let speed. All of these are different variables, okay? JavaScript does not distinguish between these variables because JavaScript is what's called case sensitive. Okay, so again, we usually, to get around these things, we usually would use either camel case or we would use snake case. We don't combine them or anything else. Now, we do have, there is this idea that you usually put constants as all caps, okay? Now, constants follow a separate naming convention from variables, okay? Now, there are usually two types of constants. We have true constants, which have values that will never, ever change when you run a program, such again, like maybe if we do pi or maybe numbers of hours in a day, right? Now, there are also values that we make constants that you don't want to accidentally change. And again, that would be maybe such as the current user's name. Now, for true instances, it's usually customary to utilize all caps and snake case if you're doing something like that. So we would be, so like if we had here, let me clear this, and we had something like tax rate. So you would put up all caps with an underscore between those, okay, utilizing snake case. Now for consoles that we create to avoid accidentally changing the value, use the same convention for as for variables, okay? So in that case, the only difference in the binding would be that we would create a constant rather than let. Okay, so let's go on to the next thing that we can talk about, and that is incrementing and decrementing. Okay, so let's say that you have a savings. So let savings is equal to 100. Now, we want to add more money to our savings. So we could say savings is equal to savings plus 1. Now that gives us 101. Here we've declared technically a new variable called savings and initialized it with a value of 100. And then we've assigned a new value to savings by adding 1 to its existing number. Okay, now this is great and all, but it's not necessarily the best way to do it. If you adding 1 to a variable is a very common task. In JavaScript, it makes it easier for us to increment utilizing an increment operator, which is a ++. Okay, so let's say that, let's do something like, let's say let stock price equal to, let's say, 6. Okay, well, if you want to increment it, you can use the ++ and then do stock price. And this will increase it by 1. Okay, if we do ++ stock price again, it will increase it to 8. Okay, so now if we want to decrement it, so the stock went down, we can do minus stock price, and it will take it back down. So in this example, we have placed an increment and a decrement operators before the variable we want to change. Now with the operators in this position, the output of the increment or the decrement operation is the variable's updated value. So for example, we have our stock price as a value set to 6, and we have the ++ stock price outputs to 7. Okay, now then we can, this is called the prefix incrementing and decrementing though, whenever we have this beforehand. Notice that again, it's before the variable, okay? Now, JavaScript also allows for postfix incrementing and decrementing. So this, this postfix incrementing and decrementing is where the operator goes after the variable. And in this case, the variable will increase and decrease by 1, but the value shown in the output is the variable's the value before it was changed. So let's go on and create up a new example here. Let's say and let's just call this donuts, and let's say it's equal to 2. Okay, so we can say, oh, not document, donuts ++. Now notice it comes up as 2, but if I call donuts, it's actually 3. Now if I do donuts minus, it comes up 3, but if I call donuts now, it is actually 2. So we initialize donuts variable with a value of 2, but then donuts ++ increments that value, but it returns the value of the donuts from before it was incremented. Now, when we ask for the value of the donuts on its own, though, we can see that the value has changed. Now, this confirms that the increment operation did, in fact, take place. So whether we use a prefix or a postfix in incrementing, decrementing, the effect of a variable is the same. It increases or decreases by 1. The only difference is how the incrementing and decrementing expression itself evaluates. Okay, and again, we'll be able to utilize this in other ways later on. Now, the last thing I want to cover today is utilizing addition and subtraction assignments. Okay, so let's go on and let's create up a new price. So let's say let price is equal to 20. And we want to increase the price. And we would say plus equal, let's say 3. Okay, well, that's going to increase the value of the price by 3. Now, essentially what price is doing, it is doing this, is price is equal to price plus 3. So this is just a nice shorthand to be able to make things go a little bit faster. So we can also do a nice subtraction in this as well. We can do price minus equal, and let's say we do 5. And notice this actually subtracts out 5. And if we look at price here, it stays there. It actually stays there, and it is instantiated in that way. We can also do multiplication and division assignments. Okay, so let's do something like let bonus equal to, let's make it 100. Okay, well, you can say bonus multiplied equal to 1.2. So increase it by 20%. Notice that bonus has now been increased by 20%. Okay, we want to, and so that's multiplying. It's multiplying across. So we can also do bonus divide equal, and let's say we want to divide it out by 2. Okay, well, notice now we get 60. So this is a great way to have shorthand assignment operators for multiplication and division respectively. So I want you guys to kind of try this out by yourselves and see if you like it. If you want more of this content, please comment, subscribe, and hit that like button, and I will see you guys next time. Bye-bye.